Absolutely. But you know what I do?
Share.
Hi, Ravinder.
Hello.
Nobody.
How's it going
Get
now?
out.
Very good.
Okay, cool.
Okay. So now here, so Queen, where is this one is? It should be good. Recording is on, right? Yeah. Can I start?
Yes.
I think you should start.
Yeah, you can start.
Okay. I'm going to first slide. Okay, my name is Ravindra. I'm going to present my presentation on fundamentals of math and statistics. And first of all, I am going to inform you that I did masters and in the mathematics, and I do not have any Canadian experience of teaching. That's why I'm taking this course to improve my skill in mathematics. And thanks for coming to my presentation to fundamental math and statistics. I am going to tell tonight about what is the basic things in mathematics. And first of all, I want to tell you that I am giving only simple examples. I am not going to in the very higher levels, just basics of the mathematics. And first is what is derivatives. Derivative tells us a functions or is changing a particular value of x. It's used and the derivative of function at a point give a instantaneous rate of a function at any given points. And second, what are the notations? Notations are we use three, like f is a function. We put in Canadian language is called dash, and sometimes we use capital D, and sometimes we use dy dx. That's the notation we use in mathematics for the derivatives. And the geometric meaning, what is the geometric meaning? So the derivative at a given point is the slope of tangent of a line and a curve. For example, I can say that if any line, horizontal line, like parallel to earth, that the slope of that line is 0. If it's parallel to the earth, that's the slope is 0. It means the derivative is 0. Second, what is the rule? How can we find the rules or the derivative of any functions? Like if we have a x raised to power n, the derivative is n, then x, subtract 1. It's very simple. First n multiply power is in front side and decrease the power by 1. Simple things. For example, I give you the x raised to power 4 and its derivative is 4x raised to power 3. Decrease the power by 1. It's very next is what is the rules, how to find the differentiations in the different kind of functions. Like if it two functions f and g, if we want to find the derivatives, derivative is we can use d and d with f and d with g. It's very simple. And I give here examples: x raised to power 4 plus x raised to power 2. And d is the front side, d goes with the x raised to power 4, and plus d goes with the x raised to power 2. And the x raised to power 4 derivative of this is power front side and decrease power by 1. Similarly, the second one, 2x raised to power 2x. Next is the rule is different in if the two functions are multiples of two functions like f and g, there is no plus and minus sign here. And rule, what's the rule? First function derivative of second plus second function derivative of first. You can change because it's plus sign, no difference between the results. If you change dfx and gx and fg dx, doesn't make any difference in the result. For example, x square e raised to power x and x square derivative of e raised to power x plus dx square and e raised to power x. That's the rule of if you find the differentiation of a multiple of the two functions. That's a quotient rule. Quotient rule means like division of two function. Division of two function is derivative of fx over gx, gx derivative of x minus fx derivative of gx divided by the square. I again give one example here. A derivative of this function, x square derivative of ex, ex derivative of x square, then x square derivative of this. Next, application. What are the application and how derivative is used to find the maximum and the minimum value, analyzing graph, increasing or decreasing. Well, in physics, we use as a acceleration and velocity to find that function. My second topic is integration. Integration is a reverse step of derivative. Reverse steps of derivatives means integration is inverse process of differentiations. While differentiation find the rate of change of integration, find the accumulated quantity, and integration find area under the curve. In a derivative, we find the slope. In the integration, we find the area under the curve. And what is there are two types of integration. One is indefinite, second is definite. Indefinite is whose derivative is the original function, and definite is under the area of the curve of two given points. If we given the 2 points, we can find the area under the two curve. Here is the examples. This is the sign. This is the sign in the first one. This is the sign of integration. And the second, if the second example, a to b, that is a definite integration. First is indefinite integral. And the second means if we are required to find the area under the curve from A to B, then we use the second one. Rules. Rules means how to find the integration. Integration means this is the rule. If x raised to power n, then divide n plus 1. In differentiation, we decrease. In integration, we increased. That is the main difference between differentiation and integration. I give example here. X square. X square means increase power by 1. Here is 2. Then integration is 3 divided by 3. In differentiation, we increase. In integration, we increase. In a differentiation, we decrease the powers. Now, then after this, what is the basic rules? Basic rules of the integration. If a function is constant, then multiplied by x. The simple things. And the integration in plus and minus rules is integration of fx plus gx. Then integration goes with the fx and gx separately. Fx and gx. I give here examples. Integration 1 plus x. Now integration goes with 1 plus integration goes with the second function. And 1 is x, second is x square plus c. That's the integrations rule. Then if there is constant here, constant always comes before the integration. C and fx. In next slide, I will give you one example. What are the applications of integration? Application means calculate area under the curve. And second is find the volume of the solid things like, I don't know, you guys know about the paraboloids, hyperboloids, something like this, and the sphere, like a football. If you find the area, we can use this integrations. And next is come to the statistics thing. So statistics is the central tendencies, mean, median, and mode. First, we will discuss about the mean. Mean is one of the most common basic measure of the central tendency. And the mean calculated by adding all the values of a data sheet and divided the value of a number of the terms. I give here example 4, 8, 6, 5, 7. And if we find the area, total number of is 5. First, add all these things. It is 30 divided by the 5, and it means answer is 6.
That's one that I definitely use in my trade, is just getting the average. That's definitely one.
Yes, that average. In sometimes we call average, and sometimes mostly we call mean. If if teacher gave a assignment to the students, how can we find the average? Add all the marks obtained by the students, and then divide the number of the students. That will become the average of the students' marks obtained by. That's a very simple thing.
Mm-hmm.
Next is the median. Median means the mid value. How can we find the mid value? Mid value means first arrange your data either in ascending order or descending order. And then need to count how many numbers you have, odd or even. And there are two different rules of odd and evens. I give you example here. Find the mean of these 12, 8, 10, and arrange this in the increasing order. 6, 8, 10, 12, 14, 16. That's in increasing order. How can we find the mean? Because these are even numbers, even number of, and I use this 10 middle two value, 10 and 12. add divided by 2, and its mean is 11, because these numbers are even.
So is that because 10 and 12 are in the middle of that set of numbers? Is
That's
that why you added 10 and 12?
No, that's in case of the odd numbers.
Okay.
If there is odd number here, like this is a 6, total number 6. If it's a 5 numbers, then you can say the 12.
Okay, yeah.
If you remove the 6 from here, then medium is 12.
Right, in the middle, yeah.
Yeah, in the middle, because in case of odd number, you can use the middle one, because these numbers are 6 total: 6, 8, 10, 12, 14, and 16. There are 6 in numbers. So in this case, the mean of first middle 2. In case of odd, you can use the middle ones. And if we remove the 6 from here, then median is 12. Then the mode, this is the last one. The mode. What is the mode? Mode is the value that appear the most frequently in a data sheet. Like the maximum number times which value appear in the data sheet. Maximum times. Maximum time means maybe 2 times, maybe 3 times. That's it. And it is one of the 3 main measurement of the tendency, like mean. And I give you example here. This the first example, 3, 4, 5, 4, and 6. Here 4 is appear in 2 times. The first one. It means mode is 4. In first example. Then the second example, 2, 3, 3, 5, 5, and 7. 3 appear 2 times. 5 appears 2 times. And in this case, mode are 3 and 5. 2 mode, not 1 mode, 2 mode. In the next third examples, 5, 6, 7, 8, 10. All are appear in 1 times. In this case, no mode.
Ravinder, I have a question for you.
Yes.
So what is knowing what the mode is? How is that useful for something? Like what would you use that for?
It shows us the how many times this appeared, the numbers, the maximum times.
Right. So how would we translate that in our lives, in everyday life? Is that, yeah, Rebecca? Yeah.
Yes.
Would it be useful if you worked at a restaurant and you had a spreadsheet and you wanted to see how much people were like, is it $50 they're spending the most? Is it like $100? Like that kind of thing?
Yes.
Okay.
The business mode is more useful.
That makes sense. Yeah.
Yeah, the business, like if somebody open a restaurant and open doing business with the gas stations, and they doing their own business, and they can the mode is important. Then even median is important, mean is important for them in our daily life.
So it's like the frequency.
Yes,
so you're
it's a frequency.
Okay.
It's a frequency, like and it is useful in the business, not in our the people who are not interested in the business. It's useless then. Yeah. So that's all my presentations. If you can ask me any questions if you want, and that's all my presentation. Thanks for coming me, and you can ask if you have any questions.
Yeah, so the tangent of the curve, that one that was started with an I there, what'd you call that? The
Tangent,
area? What was it?
yeah, it's the value of the tangents, like the slope in derivatives.
Yeah, so you called that something that there was one that started with an I in
You means the derivatives?
you had the D and then the one that
Oh
started with
yes, the derivatives.
yeah.
Derivatives.
Mhm.
Like if you go with the if you draw a line parallel to the earth, horizontal lines, its slope is 0. If any curve like in a 45 degree, then the derivative is 1, because its equation is y is equal to x. That's the line making 45 degree. So its slope is 1. If it's a 90 degree, like a horizontal and a vertical line,
Yeah.
that's infinity.
Hmm.
It-
Wow.
yes, yes.
So what you've just explained, the I don't know much about math. I'm following and I'm learning.
Yeah.
So, when you're talking about the line across the earth, and so would this be applied in flight plans, like when you're learning
Yes,
to
yes.
fly the plane?
Like this is uh, slope is 0. If you
Right,
goes like this, slope
yeah,
is increasing. Slope is
right,
increasing. Slope is increasing. Like here is a vertical lines
right.
perpendicular to earth. That is the maximum
Okay,
up to infinity.
right, right. So if somebody's learning to fly a plane, they would need to learn this math to
Yes,
understand. Yeah,
yes,
I think
yes.
that's what I need to understand. Somebody
Yeah.
who right who's just into like the times table.
Yeah,
Or if
like
So
you're
this, like this.
surveying.
Yeah, I'm explaining it. Like this is a horizontal line. It means derivative is 0. And if you goes line goes like this, increasing and increasing and increasing, here is 145. And if it goes like perpendicular, like vertical line perpendicular to earth, then its derivative is maximum, the tangent value, that's infinity up to sky, no limit.
mm,
Cool.
Yeah,
wow.
that's the use of the derivatives.
There, oh wow.
Yeah.
Hera, you said something. I just missed that. I was
Oh,
interested.
surveying. They will use like the 2 points and the
Oh yeah,
tangent
if you
and
want the
area.
integration between the, yeah, if that's to find the integration. Integration is the reverse steps.
Mm.
If you find the area under the curve, for example, I will give you one example. If you have curve like this, you need to find area from here to here. How can you find integration from 0 to this point? That will give you exact area under this.
Wow.
Oh, cool.
Yeah, that will
Wow.
give you exact area under the this area, because curve is not always in a straight line. It maybe go like this, it
Mm-hmm.
maybe go like this. How can you find? It's a simple thing is integrate from one point to second point, you can find the area.
Wow. I love how you kept saying it's simple. And I'm like,
Yeah, I
oh,
did hear him say that. It's like, okay.
It's simple to you because you have a master's degree in it. I got a C plus in math 11 and I haven't looked at it in 20 years. It is
Actually,
not simple for us, for me.
actually,
It's like
actually, I have
A,
no
B,
idea
C.
about the Canadian 12th grade mathematics. What is the standard of 12th grade mathematics in Canada? So
uh,
I know only the master degree. I did master from here. I know the what's in master, but I don't know about the 12th grade. I need to learn what they are doing here.
algebra, um, uh, word problems, like word problems, math word problems, a lot of algebra.
Yeah,
Yeah,
Mhm.
yeah,
Calculus, right?
yeah.
I know my
calculus.
son did. Yeah,
Yeah.
my son and my daughter did calculus.
Oh
Yeah,
yeah,
they're yeah. Like
oh,
you would get along with my son and daughter.
yeah.
And I
Mhm.
just like sit there and I'm philosophical.
Yeah. It
Okay.
was like it's like another language for me. So when you were showing those the
Another
beginning
language.
slides and you were showing those problems, you kept saying it's very simple. It's very simple. And I'm looking at it, I'm like, oh no, that looks like a different language.
It
I
is
was
a
like,
different
whoa.
language.
Yes.
I kind
Oh
of
my God.
glossed over because I was like, I will never use this. This is
Yes.
Okay.
Yeah.
this is not this is not applicable to my day-to-day life, and
Yeah,
Yes.
it's not in a being managed in a way where I can even integrate it into my current
Right?
day life.
Yeah.
Like again, I got a C plus and I barely passed math 11
yeah,
Yeah.
20 something years ago.
But I think math, like again, math does not interest me, but science and space interests me. That's how I do understand when
yeah,
you were doing the plane,
yeah.
and then I'm like, that reminds me. So that um, air aviation
Yes,
knowledge
yes, yes,
because I love the space
yeah,
and it's the unseen world, just as the philosopher in me, the
yeah,
spiritual, it's the unseen, and math is also
yeah,
the unseen, right? Like,
yeah.
so yeah, like, wow, yeah. When I saw the letters, I was like, A, B, C, D, E, F, G in my mind.
I give you the simple example because I
That
don't
was
know the background of your mathematics. That's why
right.
I give you simple example. Otherwise,
Yeah,
if I go to sine theta, cos theta, tan theta, that's
yeah,
very hard to understand for the people.
right.
Background is not math.
Yeah, but I
Yeah,
don't recall ever minusing one from the end for the
yeah.
power of
I remember
anything.
foil, first outside, inside, last.
Mm.
Yeah,
I remember doing
Brenda, just going to interrupt
Pythagoras
really
and stuff.
quickly because your meeting's going to end in about a minute.
Oh,
yeah,
Because you only get 40 minutes. So I'm sorry to interrupt, but I just want to make sure you have time to like finish up if there's
yeah.
anything else. Yeah,
okay, so thanks
because
for
otherwise you'll be
coming.
cut
Thanks,
off.
thanks for joining me, and thank you very much. And I
Thank you.
was thank
Thank you,
you,
Ravinder.
thank
This
you.
was wonderful, even though it was just like, oh my goodness. Yeah,
Yeah.
it was. It was. Yeah, I did enjoy it actually.